Suppose that we want to measure the length of this bar. Now, we know this is a very standard problem in physics, in many other branches of science, where we have to take some physical measurement. So suppose I take this scale and try to measure this length, and it turns out to be something. So we get one particular measurement, and that, according to our model, we can write it as y1 equal to beta plus epsilon 1. So beta is this length, the true length, and y1 is the thing that I got by measuring it, and epsilon 1 is the inevitable error. Okay, so I will take a number of measurements. That is the standard practice. I will measure it again, I will measure it again, and every time I will take the measurement of the same thing. Had there been no error, I would always get the same number, but because of some random fluctuations, I will get some slightly differing things, and as a result, I will get a system of equations. So y1 equal to beta plus epsilon 1, yn equal to beta plus epsilon n, yn equal to beta plus epsilon n. So that is a linear model. Now let us see how we shall get the least square estimator based on this. So if I write it as a least square model, a linear model, in that case I get this scenario. I have y1 to yn, then the design matrix is x1, 1, 1, 1, 1, 1, unknown beta vector is in this case just a single scalar beta, and the epsilon 1s. So what will be our normal system of equation? That is pretty easily seen. It will be that x prime x transpose x, beta equal to x transpose y, which in our case will turn out to be x being just this vector of all ones. So x transpose is nothing but all these ones lying horizontally. Then this is x, so that is x transpose x, and what is followed by this beta. So x transpose x beta is nothing but 1, 1, 1, 1, then 1, 1, 1 beta, and then again x transpose is another 1, 1, 1, 1, 1, and y 1, 1. So what is this? It is pretty simple in this case to work out. So all the ones put together, that will give rise to all 1, 1, 1, 1, 1, 1. That will be 1 times 1, 1 times 1. So it will give you just n times beta hat equal to, similarly, all these 1s, 1s, 1 and y1, y1 will give you summation yi. So it will be beta hat equal to y bar, summation yi divided by n, total number of observations. That will be simply y bar. And you know, that is a very natural thing to do, right? Even without thinking about least squares and linear models and all these things, if you take multiple measurements of the same quantity and you want to combine them into a single number in a meaningful way, taking the average is the very first thing that comes to our mind, and that's what we are getting, even without thinking about linear models. Now let us see why we believe intuitively that y bar is a good thing to do. Without using any complicated statistical term, we want to explain the usefulness of y bar to a layman. What are the conditions? What are the things that we are going to say? We shall see that from that we will get a tacitly assumed statistical model.